Thanks everyone. It's an excellent presentation we've just had on asphalt. Mine is a very, very different kind of presentation. We're just wanting to look at the idea of innovation in our road networks and whether we're opening the door for it. And what that really means is, do we have a system that really allows us to implement new technologies that come through? The answer is obviously we do, because we've got a lot of new product coming through, but there is a lot of roadblocks that we're still finding from time to time. So obviously the industry in New Zealand and the New Zealand Transport Agency are actively looking for innovation and requiring it, you might say. So that's really positive. It involves obviously being prepared to change the way we do things, change our attitudes, and possibly even changing codes or guiding documents. And this is where it becomes challenging, because it's easy to talk about innovation, but we have to actually have a system for getting rid of the roadblocks. So at the heart of it we've got to understand the concept of innovation being reducing waste and providing better outcomes. So more bridges, more maintenance, more rehabilitations without increasing cost. We do have to understand that innovation is never about cutting corners. It shouldn't be. So often when we come up with a new idea, the way it is received by the market is, why are they trying to cut corners again? But innovation is, in some industries they talk about lean thinking or lean manufacturing. Innovation is reducing waste and cost from our products and processes. It is a well-accepted concept in New Zealand already. The idea of alternative solutions, the idea of alternative bid, we see that a lot, and we get a lot of success out of that. One challenge that we face at the moment is that consultation with an agency, any road controlling agency, is often viewed as a time-consuming and laborious process with an uncertain outcome. So there is resistance to engage in the consultation process because people believe that there's a high chance of not getting the desired outcome, but the money and time has to be spent up front anyway. We've seen applications. I can personally speak about experiences where on state highway projects, the industry has come up with savings or innovations on a project that would have six-figure savings, $100,000 plus on a highway project, and that's significant. And the cost of implementing those, or the cost of the approval process, was just about as much. So the client was not able to actually get any benefit or any advantage from that innovation. So I think we can do better than that. I think we need to start looking at our processes so that we can actually implement the innovation that is happening. So there is a strong incentive for a tenderer to hold back on that and to only come forward with what they know will be pre-accepted. But it's very encouraging to see that one of the key platforms for this conference was listed as, and I'm just going to read this off, you got it there: innovation, the industry, and in particular the principal client are looking for more innovation in the M&O space for delivering value for money, improved quality, particularly in pavement and resurfacing, renewals, and customer service and satisfaction. So we do have quite a high level of confidence that we're on the same page. So the industry and the agency both actively want this innovation. So the question is, do we then have a disconnect between the intent of the agency and what's happening on the front line? So we have a policy set at a high level, and then we have the processes whereby we approve things. And this is the question that I want to explore, is, are we actually getting that outcome on the front line? Because there is a possibility and there is a danger that we can have a process that is so onerous and so time consuming and so complicated so as to remove the benefit in practice even when the intentions are right. And I'm saying this somewhat from experience, is that when we see new innovations coming in, there can be a very onerous process to get them approved. And I think for the benefit of the industry, we need to be looking at how we can streamline that. I'm going to speak a little bit about some geosynthetic solutions. Not that this presentation is about that. This presentation is about innovation and how we can accept it. But this is the area where my experience has shown me what's happening, so I thought it would be the easiest one to talk about. So geosynthetics, everyone knows what they are. They're not new. We've been using them for 60 years. And tensile reinforcement's been around for 2,500, 3,000 years. But they're still a new product when we compare them with aggregate steel and concrete and that type of thing. And when you go to university and study civil engineering, you'll spend a lot more time on learning about steel and learning about aggregate and learning about concrete than you will about any synthetic-based product. And a lot of the innovation of them is driven by the manufacturers. And there's a reason for that. It's because the manufacturers have access to the technologies and the funds to develop them. So we're talking not in New Zealand now, we're talking internationally, but big international companies that are spending a huge amount of money on developing new technologies. So there is a challenge with this manufacturer-driven approach, because what you see is that the manufacturer who has an inherent commercial benefit in a product comes up with a new solution. We can tend to think that there's more commercial benefit to that supplier than to the client. Okay? That's a way of thinking that we really need to just pick up and drop in the bin, because a lot of innovation worldwide comes from suppliers. If you think of other industries and the massive developments in IT, autonomous vehicles, electric vehicles, all that kind of thing, it's not driven by government agencies, it's driven by private enterprise. So we need to allow that to come through without a bias or prejudice that company might make some money out of it. Combine that with the obvious danger of getting it wrong, because there's a risk with anything new that you can get it wrong. And there's an obvious safety net in relying on established and well-prepared documents and manuals. So if you've got to sign something off and you can reference it, dot every I, cross every T to a manual, there's a lot of safety factor in that. Combine those things together and we have to challenge ourselves, I think, as we're really opening the door for innovation like we should be. So as I said, we're not about MSC walls or bridge abutments today, but I just want to touch on it because it's an example where I think we can, as an industry, that we can move forward on. Just touching on those terms there, mechanically stabilised earth and geosynthetic reinforced soil, most people will be familiar with those. The New Zealand Bridge Manual makes a reference when you're talking about geosynthetics to the Transfund Research Report 239. It was done in 2003, so it's quite old now, but it is still referenced in the latest edition of the New Zealand Bridge Manual. So if we go to that, we see that it refers to geosynthetic reinforced soil as being soil reinforced with geosynthetics. No surprises there. And MSC is called a generic term. So you can read what you want into that. And the New Zealand Bridge Manual, NZTA Bridge Manual, uses these terms pretty much interchangeably. So the only difference being mechanically stabilised earth could be any kind of reinforcement, including steel, and geosynthetic reinforced soil is only geogrids and geotextiles. So essentially you can say MSC wall with geosynthetics is the same thing as a GRS wall in New Zealand, according to the Bridge Manual. Now, in some countries overseas, and notably I'm going to speak about USA, they treat them differently. And the terms have a different meaning. And this is relevant to us because there's two different agencies in the United States who are referenced in our guidance here, in the NZTA Bridge Manual. The AASHTO LRFD Bridge Design Specs and certain Federal Highway Association manuals are actually referenced, so you can go use them for design. And they're using these terms different to how we're using them, so we just want to look at that specifically. Mechanically stabilised earth is where a reinforced soil mass is analysed as a structure. The geogrid or the geosynthetic spacing is quite wide apart, usually at least 400 mil, sometimes 600 millimetres apart. And we actually analyse the forces in the reinforcement layers and we allocate it to every layer so we know the forces being developed in the layer. We then assume that whatever facing we put on has to be connected to the geosynthetic at Tmax. That is, it has to be able to withstand the full strength of the geosynthetic. However, they talk about GRS. as a little bit different. The concept in the AASHTO terms of GRS is closely spaced reinforcement that works together with the aggregate to form a composite mass with predictable behaviour. That's how they define it. The reinforcement spacing is never more than 300 mil apart, and they don't analyse the facing connection. So they treat the reinforced soil mass as a composite mass that behaves predictably. So there's a distinct difference in the way those are designed. And yet we use the same terms in New Zealand. So we just want to be clear about that moving forward. But geosynthetic MSC and GRS bridge abutments can be used as a structural element to support a bridge superstructure. We know this because this is done right throughout the world. As of 2015, the US Federal Highway Administration reported there are more than 200 bridges in 44 states and territories with integral GRS abutments. Now that means they had no piles. Okay, so the superstructure was sitting on the GRS abutment. So there's plenty of case study there. That's 400 bridge abutments just in that one agency. So we know that can be done. So there's an opportunity for innovation because we don't do a lot of that in New Zealand, if at all. So going back to the bridge manual that we're currently working with, which is a great document, I'm not knocking it at all, but it refers to reinforcement elements as inextensible, then it says usually steel, or extensible, usually geogrid. Okay, so we've got some usuallys happening there. And usually steel and usually geogrid is open to a little bit of interpretation, we have found. But then it proceeds to say that inextensible steel reinforcement shall be used in certain circumstances. So therefore, if you've got a superstructure sitting on it or any structural element, or you need to limit deformation in the wall, then you've got to use steel. Okay, so this is just the documentation that we currently work under. So that actually means in New Zealand that GRS or geosynthetic MSC abutment cannot be used in New Zealand. Even if we use a geosynthetic product that limits the strain to a very, very small tolerance. And there's various definitions of that. I don't know that the American standard actually defines it. Certainly the British standard, BS 8006, defines the limit between extensible and inextensible at 1% at working strain. So if you work out the stress in your geosynthetic or your steel, if it's going to strain less than 1% over 100 years, it's called inextensible. But even though we reference that, we can't do that in New Zealand currently. However, we can readily obviously supply geosynthetics that with a working strain of less than 1%. So these are just a little bit of background to some innovations that are available to us in New Zealand. Also, one thing that our current documentation doesn't allow for is the fact that there is a better strain compatibility between geosynthetics and soil than there is between steel and soil in a reinforced structure. Okay, so the soil mass itself is not inherently stiff. It has some strain characteristics, and over the course of a structure's 100-year life, the soil mass itself will and can move a little. So to insist that we have a geosynthetic that has zero strain is not necessarily best anyway. But it does work well in the experience we've had. So one thing that is obviously clear that I haven't mentioned is that there is a provision in New Zealand to apply for a departure. So if you want to do something new, you can go along to the agency and you can say, your manual says this, but I want to do that, and let's have a look at it. And they'll have a look at it. Now, I believe that that is encouraged and supported by the NZTA, certainly at the level of engagement from people that we have here today, and I don't know who's with the NZTA, but this is, as I understand, is the policy to look at and view favourably any departure from the manual, if it can be proved to be beneficial. The practice is that there's a lot of feedback from the industry that this is seldom approved and in most cases is not now considered an option in this particular area we're looking at with the GRS bridge abutments. We have had a specific example, which I can't mention the names because it's commercially sensitive, but a very, very well-known consultancy submitted a full GRS abutment to a national infrastructure project, right through to full design, and it was accepted by the agency. Okay, they signed off on it, so it was very, very positive. They didn't win the bid, so it didn't get built, but the next job they did win, and they submitted the same design, designed by the same designer, but just adapted for the site, and it was rejected. So it doesn't seem as though we're really opening that door for innovation when we've got that kind of thing happening. Because there's a massive benefit in building these structures, not everywhere. They're mostly smaller bridges and they're mostly areas where we're expecting settlement, but there is some massive benefits if we can allow it. And to have a process, and you know, we're talking of tens or hundreds of thousands of dollars worth of design going into these, and to have it accepted on one project and the same thing rejected on another, I'd just like to suggest that we might be able to do better than that. So I've got a few slides here from earlier in the year. I went to Orlando, Florida, to the Geotechnical Frontiers conference. There's a presentation there by an engineer called Michael Simak of Earth Technologies, and he built or designed one of the first hybrid GRS abutments in America 16 years ago, and he's been monitoring it ever since. And he said we're free to use some of his slides, so just want to have a quick look at them, just as an example. So it's a hybrid abutment, not a true GRS and not a true piled abutment. It's got steel piles taking the vertical loads, but all horizontal loads, all other loads are taken by the reinforcement. So it's just an example of the kind of thing we can draw on to help our case forward with this. And what's more, the designers are quite keen to come to New Zealand and see our beautiful scenery, and they want to help us build some of these walls. So these following slides are used by kind permission. It's not a case study in the true sense of the word, because I'm just showing some pictures and giving an idea. But this is the first in North America to have this kind of hybrid abutment, and they're 6.7 metres tall, so they're significant. And there was 4 of them, 2 bridges, 4 abutments. And they look pretty standard, pretty conventional. You can drive down a New Zealand State Highway, see a lot of pictures like this. But they had the bridge seat sitting on the reinforced abutment. As you can see there are some piles in there. They've got some piles running through to take the vertical loads, but those piles are not cased, and they are working in conjunction with all the reinforced soil. There's the piles going through the earth mass. If we did that in New Zealand, we'd have pile cases around them, and the cases would be designed to be far enough away from the piles so that the movement of the soil was not interfering with it. So you know, I can send anyone more information on that afterwards, but we'll run out of time if we go into it. So just really briefly, looking over all that, I just wanted to come up with a couple of ways which I believe we could make it better. And the first thing I think is that if we have a road controlling agency that approves product, I think they should focus solely on the quality assurance of the product and not dictate design processes. That is, a product is checked and approved in such a way that the user can be sure of the integrity of the data and the quality assurance processes without restricting the designer and how it's applied. Because we've got some absolutely world-class designers in New Zealand, structural and geotechnical, and we should let them have the scope they need to design the best structures they can. Now that's a can of worms. I'm not going to win this round, because agencies love to dictate process, and I know that. But even if we could make a small step towards it, because we've been through this process with some of our products and we get full approval from the agency, okay, through the full process, and we get full approval, and they say you're absolutely happy with that product, and you can use that anywhere in New Zealand on any project, so long as you use it like this and don't use it like that. Well, what we're actually doing is we're restricting the designer on the project. The other thing we can do is that once a new technology or process is successfully used on a public project, with all the consultation and research associated with it, why can't we have some kind of formal update process? It could be an appendix, it could be a technical note, it could be something similar, whereby we can lock that in to be used by other departments of the agency so that we don't have to redo it all. It makes absolutely no sense for a bunch of consultants to spend hundreds of thousands of dollars working out whether a system is good enough to use in New Zealand, and then 6 months later we have to do that all over again, because that's what we are actually doing at the moment. So it will give the contractors much greater confidence that a submission will have a successful outcome. So that's me. We have a very dynamic industry. We've got a new government, a certain amount of uncertainty around that. When I wrote this presentation, I said we have a fantastic government, but now I'm saying we've got a new government. I don't know what they'll do. They could be good. I'm not knocking them for a minute, but it's new, and we don't know how it's going to go. We've got great people, world-class infrastructure, and world-class designers. Let's not constrain them. Let's give them the scope and the rope they need to do their job, and put these simple processes in place whereby we can actually allow innovation rather than hindering it.